Colleen Singer died of a heroin overdose on Christmas Day 2014. This is from her obituary that was published in the Bangor Daily News. She was a victim of herself, of politics, of our society's continuing ignorance and indifference to mental illness, and of our society's asinine approach to drug addiction. Beset by affective instability due to market reactivity of mood, unstable sense of self, impulsivity, a pattern of intense but unstable interpersonal relations, Colleen flashed amazing smiles, but lived an inner life where she often felt emptiness, loneliness, and depression. Colleen wanted to get back into a methadone clinic, but the legislature said no to the Medicaid expansion. It is no stretch to say that but for the veto of the Medicaid expansion, Colleen probably would not have shot the heroin that ended her life, and probably would not have had the serious recurring infections that ravaged her limbs the last couple of years. When I read this, I felt angry and sad. I'm a researcher who studies the genetics and neuroscience of addiction. But it was clear that much of basic addiction knowledge is not making its way back to our society, and certainly not making its way back to our policymakers. I took it as a challenge to go out there and talk about the science of addiction. Many of us are going to consume a drug with some abuse liability for most of our lives, but only a few of us are going to be addicts. Much of the addiction neuroscience focuses on what mediates this transition from a casual drug user to chronic drug users, why certain people are more vulnerable. Addiction is the result of our genes interacting with our environment to produce this disease state. So genes plus environment. And addiction is a chronic brain disease. It is a long-lasting disease that we can manage, but we cannot cure. It's a chronic disease much like diabetes or hypertension. We can, in fact, even specifically compare addiction with diabetes and hypertension in three ways. First, the prevalence of addiction. In the United States, the prevalence of addiction is roughly 20%. This is very similar to the prevalence of diabetes or hypertension. Secondly, relapse rate. For addicts and for diabetics, the relapse rate is roughly 50%. But how we view the relapse is very, very different. Let's say we have two individuals, an addict and a diabetic. They both have their disease under control for 10 years, and then they relapse. The diabetic goes to the doctor. The doctor says, well, we've successfully controlled your blood sugar for 10 years. It's time to readjust your medication, and we'll get this thing back under control. We've successfully controlled it for 10 years. An addict who reinitiates drug use is said to have fallen off the wagon. That's a failure of treatment. They may go to the doctor, go to abstinence, start abstinence, reset the cycle. But one is a success of treatment, the second one is a failure of treatment, even though medically speaking, they're both the same thing. Finally, in terms of genetics, how much genetic influences addiction or diabetes or hypertension is roughly the same amount, somewhere between 20 and 80% depending on the drug of abuse. These are obviously different genes, but what it shows is that genetics, the impact of genetics towards this disease is similar in all three cases. Now, since I'm a geneticist, I thought I would give you an example of my own work and how we've been able to identify genes that regulate addiction. Now, I'm lucky to work at the Jackson Laboratory, which is one of the leading genetics and genomics institutes in the world. There's just one small issue. Most of us at the Jackson Laboratory work on mice. This is literally a small issue. Now, you may wonder, well, how do you model something like addiction in a mouse? But it turns out that mice are actually very good model systems to study complex behavioral disorders. So in terms of genetics, we share much of our genes with mice, so we're very similar. In terms of brain structure, humans and mice actually have similar brain structure. Obviously, a mouse has a much smaller brain, But all the relevant circuitry is there, all the relevant cell types are there. And finally, in terms of environment and genes, we can exquisitely manipulate the environment of mice and the genetic and the genes of mice. There are hundreds and thousands of mouse model systems available for us to study. We can carry out long-term behavioral experiments in these mice where we can manipulate the environment. And mice, like humans, respond to drugs of abuse. So we can train a mouse to press a lever or poke its nose in a hole to get the drug. And in fact, in my own lab, we study cocaine abuse, and one of these mice has been given cocaine. Can you tell which one? Right, so cocaine elicits a release of dopamine in key regions of the brain. Dopamine causes hyperactivity, and that's what you're seeing on the right-hand side. These mice are hyperactive because they've been given cocaine. And in fact, we can use this hyperactivity as a measure of animal sensitivity to the drug of abuse. And so how much a mouse moves after it's been given the drug is kind of how sensitive is it to cocaine. So I'm going to take you back in time to 1951. And something critical happened in 1951 for us mouse geneticists. A colony of mice were shipped from Bar Harbor, Maine, to the National Institutes of Health in Bethesda, Maryland. Now, these mice were clones of one another. They were exactly identical. Just half of them are maintained in Bar Harbor. The second half are shipped to Maryland. And in order to maintain these lines of mice, you breed them amongst one another. And we know the process of DNA replication is not 100% accurate. There are always some errors that are picked up. So over the last 50, 60 years, you can imagine certain changes are occurring in these two populations of mice, even though they were identical in 1951. So in 2013, I tested the mice from Bar Harbor, from Maine, and from Maryland for that cocaine response assay that I just showed you, the locomotor assay. And it turns out that they're very different. The Maryland mice respond much less to cocaine. That's the green bar compared to the blue bar. Now, as a geneticist, this is kind of cool. These guys were exactly identical. What happened? So we used the process of genetic mapping, genomics, sequencing, and it turns out that sometime between 1961 and 1974, there was a single mutation that was picked up in the Maryland mice. And this mutation causes a difference in the behavior that I just showed you, in this cocaine response behavior. Now, this is one mutation out of 2.8 billion letters in the mouse's genetic code. This is like taking the combined population of India and China and finding the one individual that's culprit. And we can do this because of modern techniques and technology that has been available. Don't get me wrong, this work took 2.5, almost 3 years to do. And what we discovered was a new gene that regulates cocaine response. And now that we have this, and what we learned also from this gene is that this gene controls the structure of neurons in a very specific part of the brain that regulates cocaine response. So we started with this observation that the behavior is different. We worked hard to figure out, well, what is the genetic difference? And then once we had the genetic difference, we said, well, what does this gene do? This gene controls structure and functioning of neurons. Well, what do neurons do? Well, neurons control behavior. So we kind of come full circle. Now that we have this finding in a mouse model system, we can look in human cases and addicts to see, well, is this gene or this pathway perturbed? We could even ask the question, could we target this for therapy? Now, this kind of work, this discovery in basic animal models can take years to materialize into therapy for humans, but now we have kind of a handle that we can work on. So now that we have this handle, you can imagine that, well, let's take, for instance, someone with a genetic vulnerability for addiction. In fact, let's say for any chronic disease. In fact, look around. Most of us in this room have some family history, some vulnerability for some disease. And in fact, if you think about this disease, You're born with this mutation. You have to manage the effect of that mutation for the rest of your life. You inherited it from your parents. You'll pass it on to your offspring. This mutation is not going away. The effects of this mutation has to be managed. In my family, we have a family history of diabetes. Most males, men in my family, get diabetes in their 30s or 40s. Now, I can't control my genetics, so I try and control my environment. I try and eat healthy. I try and exercise. My daughter will laugh. But I know that with proper environmental manipulation, I can kind of prevent or delay the disease. But if I do get the disease, then I have to be treated for the rest of my life. If I don't get that treatment, I will die. And this is the dissonance with Colleen. We knew the treatment she needed, and we failed to provide it, and she paid for it with her life. Modern addiction science teaches us that someone like Colleen, addicts, need medical services. They need pharmacotherapy to stabilize their addiction. Many addicts have other secondary comorbid diseases, such as mental illness. Now, in fact, many people use drugs of abuse because they have the mental illness. The use of addictive substance is a symptom of the disease, of the mental illness. They'll also need behavioral therapy to change their pattern of behavior. They may need legal services. They may need family child services to reintegrate into society. They may need educational services, vocational services, housing to start work and live and be a productive member of society. This is holistic, evidence-based addiction treatment. This has been proven to work. And this brings me to what I think is the real reason why the state of Maine failed Colleen. This is expensive. Treating someone at this level, customized treatment, long-term is very costly. But what is the cost of not taking care of addicts? In the United States, we spend $700 billion, which is the cost of addiction. This is healthcare cost, lost productivity, the criminal justice system. Yet, we only spend $10.3 billion on prevention, treatment, and research. We're spending the money, it's just which pie do we want to put it in? In the state of Maine, it's even worse. This ratio is even more skewed. We've got to correct this discrepancy. Addiction is a chronic brain disease with clear genetic and environmental underpinnings. Addiction science has taught us how to treat addicts effectively. If we want to prevent the future Colleen Singers, we've got to have the wisdom to listen and act. Thank you very much.